we are going to go ahead and continue with our example 5.5. So we have an acceleration here and we want to know the resultant force acting on the ball that has some mass here. Okay, so remember that F equals mass times acceleration. So that's exactly what we need to do to find our force. So we take our mass, which is 0.40 kilograms, and we multiply it by our acceleration, 3.0 I hat plus 7.0 j hat. Okay, and this is in meters per second squared. Okay. So our force then is going to be 1.2 I hat plus 2.8 j hat, and that whole thing will be in newtons. Okay, so this is our resultant force. Now we want to find our magnitude and direction. So our magnitude of a general vector, so if I say some vector r has these components, our magnitude will be rx squared plus ry squared, and take the square root of that. And the direction will be the tangent inverse of r sub y over r sub x. Okay, so this is our magnitude and this is our direction. Okay, so this is just little reminders for us when we're going through this. Okay, so if I want to find our magnitude, I'll take my x component, which is 1.2, square it, plus my y component, which is 2.8, and square it, and then square root the whole thing. And plugging that into your calculator, you'll get 3 newtons is your force. Okay, your magnitude of the force. Now if I go ahead and find my direction here, so this will be tan inverse of 2.8 over 1.2. I get 67 degrees as my direction. Okay? All right, so I'm going to go ahead and continue with another example. Okay? It states a particle of mass m equals 4 kilograms is acted upon by 4 forces of these magnitudes, F1, F2, F3, F4, with the directions as shown in this free body diagram. And it asks, what is the acceleration of the particle? Okay, so again, F net equals mass times acceleration, and F net also equals the sum of each individual force. Okay, and these will have directions, so they will be vectors. All right, so you can see from this diagram that force 2, 3, and 4 all lie on the xy plane, or xy axis. Okay, the x or the y axis. So F1 is the only one that we need to be concerned about for the moment. So it told us our magnitude, but we need to figure out in what its components are. So we need to find first F1. I'm going to call it F1 comma x. Okay, and then F1 comma y. Okay, so that's going to denote the F1 vector and the x and y components. Okay, now you can use your trigonometry, and we also talked about this last week in last week's videos. We can calculate this it's going to be the magnitude of the force, okay? And it'll be multiplied by however you get this component here. So it'll be adjacent over our hypotenuse here, F1. Okay, so this will be cosine theta, or 30 degrees. Okay, so this will then be 10 newtons times cosine of 30 degrees. Okay, so that is our x component of the F1 vector, or force. Okay, so plugging that into your calculator, you get 8.66 newtons. Okay, and we'll do the same thing here. So it'll be F1 times sine now. So if we get the y component here, this will be F1 comma y. Okay, the y component here, that is opposite over hypotenuse. Okay, so cosine. So we get 10 times sine of 30 degrees, and we get 5 newtons. Okay. All right, so if I want to write this in its full form, I would say, of the force, so F1 vector is now going to be 8.66 newtons I hat. Or actually, I can put the newtons on the outside. Okay, so 8.66 I hat plus 5.0 j hat. Okay, and this is in newtons. Then I can go ahead and start with my other vectors, my other forces. So I'm going to go to F2, okay, and it already told me the magnitude of it is 40 newtons, okay, and this is in the y direction, so I'm going to say j hat, okay, but it is pointing in the negative y direction, so I'm going to put a negative in front there. Okay, I insert that. Okay. All right, now to F3, it's going in the negative direction again. Okay, it's going in the negative x direction now, and its magnitude is 5 newtons. So I'm going to say 5 I hat. And for F4, it's positive in the positive y direction. So I'm going to say it's 2.0, j hat. Okay. All right, so that was the first step to kind of figure out all of our directions and everything, all of our components. Now we need to find our acceleration of the particle. Okay, and we need to figure out what our net force is. So F net is going to be the summation of all of these, or adding all of these up. So we'll say F1 plus F2 plus F3 plus F4. Okay? So if we add all of these up, we can do it by component. So let's go ahead and group them. So we have I'm going to round it. Well, I didn't round it. Never mind. 8.66. Okay, that's in the I direction. What else is in the I direction? Just F3, so minus 5.0. And that's I hat. Plus whatever's in j hat. We have 5.0 and negative 40 and positive 2. That's in j hat. Okay. So we get 3.66 I hat, oh, this is newtons, plus a negative 33 J hat. Okay, so that is our net force. Now we want to find our acceleration. So from this equation, we can say acceleration is F net over mass. So what I'll do is I'll say acceleration is our F net divided by our mass, which is 4 kilograms. Okay, so we'll plug that in. 3.66 I hat minus 33 J hat divided by 4 kilograms. Okay, then we put that into our calculator and we get 0.92 I hat minus 8.25 J hat, and this is in meters per second squared. So this is our acceleration vector. Okay? All right. So with that, we need to understand our weight and gravitational force. So the gravitational force is, okay, hold on. So let me back up a second. So weight is the gravitational force that is the net force on a falling object, or its force due to gravity on an object of mass m. Okay, so weight is what we typically think of when, remember how I said mass is related to weight, but it's not really weight, it's different. Okay, so it's related to weight in this way. So weight is equal to mass times acceleration due to gravity. Okay, and that is g. Okay, so again, this is, weight is going to be measured in newtons. Okay, and so let's go ahead and look at an example of this. So we have a farmer that's lifting some heavy rocks from a field to plant crops. He lifts a stone that weighs about 180 newtons. What force does he apply if the stone accelerates at a rate of 1.5 meters per second squared? So this is where we're going to have to create a diagram in order to understand really what is going on. Okay, so if we have a rock, I'm going to just draw it as a point, okay, and it has some sort of weight, call it W, okay, and this farmer applies a force in which, that should be a straight line, a force in which the stone accelerates, or the rock accelerates towards him. Okay, so this is where we have that positive acceleration. Okay, so we want to note that our weight is 180 newtons. Okay, we are going to want to know the force. We know its acceleration, but we don't know the overall force, so we need to figure out the mass of the rock. Okay, then we can find the force, okay, that is required for the acceleration to be 1.5 meters per second squared. Okay, all right, so with this first step, we can use the weight of the rock in order to find the mass, since weight is equal to mass times gravity. Okay, so we can solve for mass here, and we will have to finish that off in the next video.